DIF. This is decimation in frequency. Okay. And why the name is DIF? If you derive the equations start deriving the equations for this DIF, no, you will be decimating the given x of k. That is frequency domain sequence will be decimated here. If time permits, later we can have a look at the derivation. Okay. But since we have already seen the derivation of DIT FFT clearly, if you go through the derivation that is given in the note, you will be able to understand it better. Okay. So here this x of k, this endpoint x of k will be decimated into two numbers of n by 2. And this again will be decimated into two numbers of n by 4. Now, since we are decimating the frequency domain sequences, we are naming this method as DIF method. Okay. The procedure is the same. Again, we have to express n as 2 power m, where m represents the number of stages of computation. So, if n is equal to 8, express it as 2 power 3. So, it requires 3 stages of computation. What is the basic difference that is involved in computing this DIF FFT method is, the very first difference is input will be in normal order. Normal order. Input is in normal order. Take down that. Input should be in, it is given clearly here. What is the difference between DIT and DIF method? In DIF, input will be in normal order, whereas the output will be in bit reversed order. This is a contradiction to DIT method. It will be the vice versa in DIT. Okay. So since the output is in bit reversed order here, the output that we get is not in normal order. It is in bit reversed order. So what you have to do in DIF is, you have to go for one more extra step. After finding the third stage of computation for 8-point DFT, the output that we get will be in bit reversed order. So you have to take and write it in normal order. That will be the extra step that you have to perform in DIF. It should be written. It should not be in the bit reversed order as such. You should not write the output as such, whatever you get for third stage. It has to be again written in normal order. That is one additional step that you have to perform. Okay. The other difference, as I told you, the time domain sequence is decimated here. Here the frequency domain sequence is decimated. One more difference is the butterfly structure. With respect to the butterfly structure, there in DIT FFT, we might have obtained, we might have drawn this butterfly structure at the end of the 2-point DFT computation. Is it not? The basic butterfly structure, if I take, we might have drawn the butterfly structure at the end of the DFT computation with phase factor mentioned here. This is the basic butterfly structure for DIT. Whereas for DIF, the butterfly structure should be at the beginning and the phase factor should be at the end. Just the reverse. First you have to start with the butterfly structure, then it should be multiplied with the phase factor. Whereas here it is, first it should be multiplied, the second number, it should be multiplied with the phase factor and then it should be added. Whereas here, first it passes through the butterfly and then it gets multiplied with the phase factor. So what will be the output here? Note down this. This is the basic structure for DIF. This will also be asked in 2 marks. What is the draw the butterfly structure, basic butterfly structure for DIF FFT. It should be at the end and here it should be at the beginning. Phase factor, of course, it should be outside the butterfly structure. Here again, it should be outside the butterfly structure and here also it is outside the butterfly structure. Now, with this structure, what will be the output that we get here? The output that we get at this node will be, at this node it will be, A is coming straight away, B is also coming here. So this is A plus B, A plus B. And at this node, what you will get, this is A and this is minus B. So A minus B will be there in this node. Here it is A minus B. Now this A minus B will be multiplied with the phase factor and you will get the second complex number. So that there will be 2 complex numbers involved in it. Again, I will get 2 complex numbers at the output also after passing these 2 complex numbers through this butterfly structure. So there will be two complex numbers at the input as well as at the output. Is it clear? Have you drawn the basic butterfly structure? And one more difference is to be noted is here in DIF method, the order of stages of computation will be reversed, which means here this will be 2 power 3, 2 power 2, 2 power 1. So in the first stage, we have to compute 8-point DFT and 4-point and 2-point. After 2-point, we will get the output in bit reversed order. You have to write it in normal order. Only then your answer will be correct. You will get full marks. These are the basic differences between DIT and DIF method. Is it clear? Shall we do start a problem now? This is the basic butterfly structure. As you can see, not the basic butterfly structure. This is for n is equal to 8. As you can see, first stage is 8-point DFT. So 8-point DFT, initially you have to draw the butterfly and then you have to write the phase factors as a reverse of DIT. So phase factors involved for 8-point are mentioned here. Second stage is 4-point. Again, first initially the butterfly structure, then the phase factors. For 2-point DFT, it is not necessary to mention the phase factor at the output because it's always 1. Finally, you are going to get the output in so this is the input. Input is in normal order. Output will be in bit reversed order. So we have to take and write the output in normal order. Okay. Do the same problem, 4 2s and 4 1s. Take this problem, 2 comma 2 comma. Take that. X of n is given as is this clear? Any doubt in this? Any doubt in this? See, that days during lab class, someone asked that for linear convolution, we are finding the starting point. For circular convolution, we are not finding the starting point. Why is it so? Right? The reason is linear convolution. If you take the summation, it is from n is equal to minus infinity to infinity. It will have infinite number of samples. So you should know. But after finding linear convolution, you will get only finite samples based on the starting point of x of n and h of n, because it is one of the sequence will be folded, it will be shifted and multiplied and added together. So it is definitely required to find where this y of n starts, because the length is from minus infinity to infinity. But it is not the case in circular convolution. The reason is circular convolution will have only finite number of input, finite number of samples at its output also. The same number of samples you will get at the output of circular convolution. Okay. Will you start doing this problem now? Yes. Can you do this? You have to find 8-point DFT using radix 2 DIF FFT. How can this be done? Yes. Can you solve this? Draw 8 lines. Okay. I can make use of this. I don't know if I'm able. Draw 8 lines like this. Start with 8-point DFT computation first. Write the input as such. Input is in normal order. Write it as such. 2 2 1 1 1 1. Draw the butterfly structure for 8-point DFT. Initially, there should be butterfly, and then it should be the phase factors has to be mentioned. So draw the butterfly structure carefully. Hope the screen is visible. For all the 4 lines in the below lines, you have to mention -1 within the butterfly structure. The procedure remains the same. -1 here, -1, -1, -1. Outside the butterfly structure, you have to mention the phase factor. It is -1 by root 2 minus j by root 2. This is minus j, and this is 1 by root 2 minus j by root 2. Hope this is clear. Now find the output of this. Yes, anybody want to ask anything?
Ma'am, here how to write the inputs, ma'am?
Normal order, as such, how it is given in the question. The same order you have to write. In the question, it is mentioned that x of n is equal to 2, 2, 2, 2, 1, 1, 1, 1. The same order I have written here. 2, 2, 2, 2, 1, 1, 1, 1. First stage of computation is 8 point. Is it clear?
Okay, ma'am.
Try to find the response of this. See, and one thing to be noted in this is also a 2-mark question, which is called in-place computation. Okay, what is meant by this in-place computation is, see, there are 2 inputs and 2 outputs. If I take a butterfly structure, basic diagram. Likewise, if I take 4 also, 4 inputs, 4 outputs is going to be there. Okay, and for processing this, for doing this calculation using a computer, we need 2 locations to to store these 2 inputs, right? 2 memory locations are required to store input. Likewise, 2 memory locations to store output. So this requires 4 different memory locations, is it not? But instead of using 4 different memory locations, initially I can store A and B, which are the inputs. These are the inputs, right? Initially, this can be stored in 2 different memory locations. Okay. And after finding the output, once this computation is over, we no longer require this inputs, right? We have completed the computation. Calculation is done. So after this calculation is being done, we no longer require these 2 inputs. So what we will be doing here is, we will be storing the outputs of this computation in the same place as that of the inputs. So the same memory location that we used to store the inputs can be used for storing the output also. That is what is called as in place. That is, in place of inputs, we are going to store the outputs that we get from the calculation. So we can name this as in place computation. So if at all, if it is asked in 2 marks, what is in place computation, you have to explain it like this. In all the books, suppose if you are getting the book, if you are buying a book, in all the books it will be given. Especially Ramesh Babu book, as I told you, many 2 marks with the answers will be given at the end of each and every chapter. Okay, so this is called, this concept also, it should be known to you. What is in place computation? Instead of 4 memory locations, we can very well use the memory locations that are used to store the input, to store the output. In place of this, we are storing the output. That is why it is called as in place computation. Hope it is clear to you. You can have you completed 8-point DFT? Will you take this as a homework? First, let me tell me what you will get at each and every node for 8-point. 8-point alone will be difficult for you. 4-point and 2-point, you can very well do it. Yes, I'm writing the output here at this place. What will I get here at the first line, first node, at this node? What will I get? Can you say? It is 2. 2 coming straight away. This 1 is coming. If you don't understand, you please listen to this. Hope the screen is visible. 2 plus 1, it is 3. To this node, why I'm writing it here is we have to multiply, we have to write, that is, we have to do all these multiplications with the phase factors for the last 4 lines. That is why I'm leaving some space and writing the output here. At this point, what I'm going to get, this is 2 coming straight away. Again, 1 is coming here. So 2 plus 1, 3. Can you say what I will get here at this point? Yes, one of you quickly. To this
Again
node,
3, ma'am.
again 3. 2 plus 1, which is 3. Fourth node is also, this is 2. This is 1. 2 plus 1, 3. Correct. What I will get at this node? Yes, to this point, what are the signals that is coming? It is 2. மேல இருந்து வரத ஃபர்ஸ்ட் எழுதிக்கோங்க 2.
1, ma'am.
நோ, மேல இருந்து வரத ஃபர்ஸ்ட் எழுதிக்கோங்கன்னு சொன்னேன் நான் உங்களுக்கு இல்லையா? To this node I have to find and then I have to multiply it with the phase factor. That will be correct. So to this node, what I'm going to get? To this point, it is 2 minus 1 into 1. Final answer சொன்னீங்களா நீங்க? Okay.
Yes, ma'am.
Okay. இந்த பாயிண்ட்ல என்ன வருது எனக்கு? கரெக்டா எழுத தெரிஞ்சதுன்னா ஓகே. 2 again minus 1. 2 minus 1. இந்த நோட்ல வருது. இது this should be multiplied with the phase factor. So the ரெண்டையும் multiply பண்ணி எனக்கு இங்க ஆன்சர் சொல்லணும். Likewise at this point, this is 2 minus 1 into minus j. So it is minus j. Answer is minus j. To this node, again it is 2 minus 1 into this value. You have to multiply this 2 minus 1 பண்ணிட்டு தான் இதை multiply பண்ணணும். So what is the answer you are going to get? It is minus 1 by root 2 minus j by root 2. Here it will be 1 by root 2 minus j by root 2. Is this correct? Is this correct?
Yes, ma'am.
தப்பா எழுதிருக்கேன் நான். phase factor கரெக்டா எழுதிருக்கேனா? Is this correct? What the phase factor I have written? W80, W81, W82 and W83. What is W81? Check பண்ணுங்க.
Second one is 1 by root 2 minus j by root 2, ma'am.
Very good. This is 1 by root 2 minus j by root 2 and this should be minus. This is minus and this is plus. Okay. நீங்க கரெக்டா போட்டிருக்கீங்களா எல்லாரும்? இல்ல இதே தான் போட்டிருக்கீங்களா? Always it is 1 by root 2 minus j by root 2 minus j minus 1 by root 2 minus j by root 2. Now this first stage of computation is over. You go for the second stage and then the third stage. Will you complete this and come? Do you have any doubt in solving this? The same procedure. Only thing is phase factor will be outside the butterfly structure. Initially you have to draw the butterfly. Any doubt in solving this? Will you be able to give the answer for this in the next class? Yes? Kindly respond.
Ma'am, the final answer getting for 2-point DFT is the answer, ma'am.
That is the answer and that is in bit reversed order. As I
Okay,
told,
ma'am.
the answer that we get will be in bit reverse order like this. It will be 0. This sample will be 0. This sample will be 4. This is 2 and this is 6. 1, 5, 3 and 7. This will be in bit reversed order. While writing the output, you have to take and write it in normal order. You have to write it as y of n or something, x of n, whatever it may be. Sorry, x of k you will be writing, right? X of k You will be writing first x of 0, and then you have to write x of 1, x of 2. That is x of 2 is this has to be written here, x of 3. Like this, it has to be written in normal order. You have to write this in normal order.